Hello, friends. Welcome to another session, which is one of the most important topic, or I would say, most important topic in terms of concept. Uh, yeah, we may not see the maximum number of questions coming out of this topic in CAT, but a couple of questions, or sometimes three questions, come out from this area are absolutely very important. Why I say so? Because a lot of us were not comfortable about this topic when it was taught in high school or in school, and we tend to keep this topic to for the end of our CAT preparation, and finally don't get enough time to master that topic completely. So today we are going to talk about permutation and combination. Permutation and combination, which to me it's not at all a difficult topic, but it's a topic that requires the most amount of conceptual clarity so that you don't get lost into the wordings of the question. If your conceptual clarity is there, we should be able to solve this. But for overall P and C, it's one of the most concept heavy area. So please be attentive. And I can guarantee you, if you spend this session with me, will be able to understand the nuances of PNC, and you will be start trying your hands even in the most complex problems in PNC. What we'll do today is we'll talk about the fundamentals as we do, and then we do a follow-up session on problems. Two follow-up sessions. First session will be on the basic problems, and the second session will be on a little advanced level problems. So we'll cover this entire topic in three sessions, but today's session will be talking about the concepts, which is very important before we jump into the problem sessions. So without further ado, let's get started. So when we talk about permutation combination, forget about the bigger names of what is permutation, what is combination. I'll come to that in a bit. But it's all about choices, the number of choices you have, the number of ways you can do a certain task. It's all about that. So it's about choices, about number of ways you can do a certain task. So for example, let's start with a very basic example. Okay, so let's say there is a two black door, and you have three red doors. Okay, now let's say this is for entry, and for exit, what you have, for let's say you are entering a room, you have one black door, and let's say you have three red doors. Okay, so you, for entry you have two black doors, three red doors, and for exit you have one black door, three red doors. So if someone asks me how many ways to enter the room, you know there are five doors, two black and three white. So basically I can write two black and three red. So total five ways, right? And similarly, if I ask you how many ways to exit the door, you can say there is one black door and there are three red doors. So there are four ways to exit, right? Now, where we are adding. Now, if you ask me how many ways to enter and exit, so this is the most important piece. How many ways to enter and exit? So let's say if you enter through this black door, let's say this black door number one. If you enter through this black door, you have an option to enter through this black door, 1, 2, 3, 4. So you have four ways to exit. So the moment you can enter through this, you can exit through either of 1, 2, 3, and 4. Similarly, if you enter through this black door, you have again four options to exit. You have entered through this red door, you have again four options to exit. So for every entry, you have four options to exit. So we can say the total number 5, for 5 entries, we should have 5 into 4, 20 ways to exit. So total there are 20 ways you can enter and exit the room. So I hope this part is clear. This is the most important fundamental part. So the number of ways you can enter for each time you entering through a particular door, you have 4 options to exit. So what is the fundamental difference in the first two and this problem? So in the first two problem, the choice we were making to enter through a door is affecting other options. So what I mean by that, hence add. So basically the choice is affecting other options means if I choose just in the first case for only entering, if I choose door 1 to entry, I cannot choose, let's say door 2, 3, 4 or 5 to entry. So I can enter by only one door. So if I enter by first door, I will not have option to enter through 2, 3, 4, and 5. So the choice I am making in the first one, same as exit, the choice I am making, it will automatically nullify the option of choosing any other. So that's why it is addition. So basically the choice you are making is affecting the other options you have. In the second case, the choice is not affecting other options. So that means if I enter through 1, I have option of doing 1, 2, 3, 4 to exit. If I enter through 2, I have still option to exit through 1, 2, 3, 4. So that's not getting impacted. So the option of exiting is not getting impacted by the option I'm making to enter the door, right? So hence multiply. So this is most important part of your permutation combination, to know when to add and when to multiply. So when to add is basically when your option that you are choosing is impacting the other available options, then you add. When in the option you are choosing that's not impacting the other available options, it's basically multiply. So for each option you choose, you have all the same options to choose the other side of the problem. So if you are entering through 1, you have all the 4 options available to exit. If you're entering through 2, you have all the 4 options to exit similarly. So that's why we multiply. For each entering option, you have 4 exit options, and that is not impacted by the option that you choose to enter. So this is basically the fundamental part. The next part is basically where we understand when to do permutation and when to do combination. Okay. Let's say there are 3 digits or 3 words you have A, B, C. Or let's say not A, B, C, let's say you have 3 person, Ram, Sham, and Joe. You have 3 person and you have 3 digits, 1, 2, 3. Okay. Now, if I ask you, choose 2 out of 3 and form a group. So basically, how we can do for Ram, Sham, and Joe? Let's say this is R, S, and J. So you can either do Ram and Sham, right? You can do Ram and Sham. You can take Sham and Joe together, or you can take Ram and Joe together. These are the 3 possibilities that you can make, right? And here you can take 1, 2, you can take 2, 3, you can take 3, 1. But the numbers that gets formed here is 1, 2 can be 2, 1, 2 or 2, 1. 2, 3 can make 2, 3 and 3, 2. 3, 1 can make 3, 1 or 1, 3. So there are 6 possibilities here. There are 3 possibilities here. So what I'm trying to say is, if you were choosing certain numbers from a given set of numbers, and those choices internally arrangement of those choices does not make any difference. So Ram and Sham, you choose, or you write it's Sham or Ram. It's basically the all the same thing. But if you choose 1 and 2, 12 is our number, 21 is another number. So your internal arrangement of the choices is is a significant one, or can be different, can create a new group or a new number. Then you have to arrange them together. So the first part is called combination, where the arrangement does not matter. The second part is called permutation, where the arrangement matters. So normally combination is denoted as NCR. So NCR means N is basically the number of item you have. So this is the total item, and R is basically choosing at a time. So in this case, it will be 3C2. 3C2. And how to calculate that, I'll give you. But understand that NCR is basically the notation of combination, and NPR is basically the notation of permutation. So again, N is the total item and R is the number of items you choose at a time. So basically, in this case, it is 3C2 and 3P2. Okay. Now, how to calculate this NCR and NPR? But most importantly, what we need to understand from the previous step is that within the internal choices, internal arrangement of the choices matters, then you should do permutation. When the internal arrangement of the choices does not matter, then you do combination. We'll solve more problems to clarify your concepts further, but this is at a fundamental level you should know. Now, what is NCR? NCR is normally denoted as factorial n by factorial n r divided by factorial n minus r. Okay. And what is NPR? NPR is factorial n by factorial n minus r. Okay. So NPR is nothing but your NCR into factorial r. So why NCR is getting multiplied by factorial r to get NPR? NCR is basically talking about the choices you make. So this talks about number of ways to choose r items out of n, and this talks about arrange the selected r items internally. So once you choose those r items, how you can arrange them internally, that's what talks about r factorial. But this is a very important formula. All these three are very important formula. We will try to solve mostly by logic, but these are the few formulas you should understand. And then there are few enhancements or few extensions of these formulas which you also can remember. Is NCR is NCN minus R. Okay. Similarly, we can say NC0 is 1. You can prove it. Factorial 0 is 1. From there, you can do it. Similarly, we can say NCN is same as NC0 as equal to 1. Because NCN is NCN equal to NCN minus N, like using this, NCR is NCN minus R. NCN should be NCN minus N, NC0, both the same. If you have NPN, that is denoted as factorial N. Okay. So these are the 3-4 things you can remember as an extension of the formulas, but these are the primary 3 formulas. These are the primary 3 formulas, and these are the extension, the right sides ones are the extension. So this is the formula base of it, and this is the only formula we will use. But the main crux of the problem lies in understanding the logic. And that's what I'm trying to explain. First, we explain when to sum, when to add. Then we explain when to use permutation, when to use combination. Okay. Now let's move on and take one or two examples and see how we can solve it. Okay. Let's say you have 5 digits, and let's say they are 1, 2, 3, 4, 5. Let's say you have 5 digits, 1, 2, 3, 4, 5. How you can solve them to make a 5 digit number? How many 5 digit number you can make without repeating any digit? So if this is the thing, so let's say there are 5 digit number and I have to make, there are 5 digits available and I have to make 5 digit number. So basically then I can say 1, 2, 3, 4, 5. These are the 5 places. Okay. Now these are the 5 places. I can choose the first place. So let's say this is the first place. This one is the first place. And the first place can be filled by any one of the 5 numbers. So 1, 2, 3, 4, 5. I can fill this place with any one of the 5 numbers. So the first place can be filled by 5 ways. For each of these 5 ways, I can select. So basically, you cannot repeat. So let's say you have put 1 in the first place. So then 2, 3, 4, 5 is only left to choose in the second place. So this is, let's say this is the second place. Now to choose the second place, you have only 4 options left, because one of the options between 1, 2, 3, 4, 5 is already taken in the first place. So you have 4 options to choose here. Similarly, you will have 3 options to choose in the third place. You have 2 options to choose in the fourth place, and you have only 1 option to choose in the fifth place. So this is nothing but 5 factorial or 120 ways. Okay. 5 factorial or 120 ways. And if you do it through formula, this is through logic. If you want to do formula, 5 digits I have to choose, and I have to choose 5 digits out of the 5 digits. So it's 5 C5 into, and then the internal arrangement of those digits also matters, because that's where you get different number. If you have 1, 2, 3, the way you arrange 1, 2, 3, each time it will give you a different number. So internal arrangement matters. So it will be factorial R, so which is same as 5P5, same as 5 factorial or 120. Okay. So this is nothing but your NCR, choosing 5 digits out of 5 digits and then arranging internally those 5 digits gives you 5P5 or 5 factorial, which is 120. Okay. So this is the understanding on how to choose. Now this is without repeating. Okay. Now let's say you can repeat. Let's say you can repeat. If repeat is allowed, then how it will change? If repeat is allowed, that means you have 1, 2, 3, 4, 5 place. So this place you can choose any 5 number. This place also you can choose any 5 number, because your condition of you have already chosen the number cannot be chosen. So that's why the 5, 4, 3, 2, 1 was coming. You don't have that restriction anymore. So you can choose 5 numbers for each of these places. Any 5 number you can repeat. So this will become 5 to the power 5. Okay. So understand the difference between 5 factorial and 5 to the power 5. The first one is when the repeat is not allowed. You have chosen a number in one place, you cannot choose it for any other place. And when the repeat is allowed, you can choose any number at any place, no matter whether you have chosen it earlier or you have not chosen it earlier. So 5 number possible in each position. So it's 5 to the power 5. So this is a very important problem for you to understand in this way. Okay. So moving on. Okay, before that, there was one more formula I thought of covering. You can remember this. NCR is maximum when R is equal to n by 2 or R is equal to n plus 1 by 2 or n minus 1 by 2. So this is if n even, this is n odd. Okay. So this is a formula you can remember, depends on the volume you can use when NCR is maximum. Moving on, let's say you have, now we were talking about, you have 1, 2, 3, 4, 5. In the previous problem we were talking about, you have 5 digits which are unique. So basically 1, 2, 3, 4, 5, all of them are unique digits. Now think of, if you have, let's say 1, 2, 3, you have 3 digits which are unique. Now if I give you 1, 2, 2, I am still giving you 3 digits, not all are unique. Okay, not all are unique. So how, so many ways you can select 3 numbers. You can select 1, 2, 2 only. Now, okay, 3 digits, 3 numbers. So let's say you have to find 2 numbers out of these 3 numbers. So in the first case, you can do 1, 2, 2, 1, 3, 1, 1, 3, 2, 3, 3, 2. So you can make all these 6 possibilities. But in this case, what you can make is 1, 2, when you choose 1 and 2, or 2, 1, or 2, 2. Because 2 and 2 are same, you cannot make other digits which are, you cannot make the different numbers by selecting 2 twos, or you choose any 1, 2 with the 1. It will be same as if you choosing the other 2 with the 1. So that does not make difference. So the number of numbers you can make is reduced, because there is a the numbers are not unique. So the formula for this is if out of n items, p are of one type, q are of another type, and r are of another type, then number of arrangements possible, is equal to factorial n divided by factorial p, factorial q, factorial r. Okay. So this is the formula. So if you have p of certain type, q of certain type, r of certain type, then factorial n by factorial p, factorial q, factorial r is the answer. So in this case, you know, you have 3 digits. So what we were doing here is 3 digits, so factorial 3, but 2 of them are of certain type. So divided by factorial 2. Okay. So factorial 2, because 2 of them are of certain type. So factorial 3 by factorial 2, you get 3 as an answer, which is this 3. And in this case, you don't have any commonality, so that is factorial 3 only, so 6 as an answer. So understand this, if out of n items, if you have p item of certain type, q items of another type, then it will be n factorial n by factorial p into factorial q. If you have r also of certain type, then factorial n by factorial p, factorial q, factorial r. So for example, let's take an example. Let's take the word independence. Okay. How many ways to arrange? Now, if we have to do this, then how many words does it have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my n is 12 here. Out of that, how many of which types? So I have I how many times? I have 1. I have for 1. Then n I have for 1, 2, 3. So n is 3. Then I have d for how many times? 1, 2. So I have d for 2. Then I have e for 1, 2, 3, 4 times. So I have e 4 times. Then I have p for 1 time. 4 to 6, 9, 10, 11. And finally, I have c for 1 time. Okay. So these are the breakup of this 12. So then number of ways to arrange is factorial 12 by more than once. I have n, d, and e. So n is 3 times, so factorial 3. D is 2 times factorial 2. E is 4 times factorial 4. So this should be your answer. How many ways to arrange this? Okay. So I hope this is clear. So this is another very important part of your permutation combination concepts. The last part we will cover in terms of concept and close the session is basically the circular arrangement. And why it will be different from a straight line arrangement. So let's say you have 3 or let's say 5 friends, A, B, C, D, E. Okay? You have put them in a bench, which is a straight line. So A, B, C, D, E. So there is a straight way to see which is the first place, which is the second place, third place, fourth place, and fifth place. Okay. If it is a straight line. So every time you change the person in the first place or second place, it will completely completely create a new arrangement. But when it comes to a circle, say you have A, B, C, D, and E, no matter from which side. So I can start seeing from here. I have A on my B. If I'm sitting at A, then E is my right and B is my left. Okay. So if I'm seeing from A's perspective, it is A, E, D, C, B from the right. But if I'm seeing from left, it will be A, B, C, D, E. So when something is in a circle, you can't assign a position. You can assign a position to everything. So for some time, if I start looking from A is the first position. If I look from E is the first position. It does not matter. It matters from how you are seeing this. So it's not a straight line where it is fixed first, second, third, fourth, fifth. So what we have to do when it's a circular arrangement is we have to fix one position. Okay, we have to fix one position. So if I have to fix one position, let's say I have fixed the position of A. Now I'm seeing from A's point of view. So then and arrange the rest. Arrange the rest. So in this case, I can do it in factorial 4 ways, or you can say n minus 1 factorial ways. Right? So when it's a circular arrangement, it always the possible way of arranging the number is n minus 1 factorial ways. N minus 1 because you have to fix one position and then arrange the rest according to that particular position. You can do B, C, D, E, you can do B, D, C, E, you can do B, E, C, D, V, whatever, but you have to fix A. A is your starting point or the anchor point, and from A, you are trying to figure out the others. The one condition is if clockwise and anti-clockwise arrangements are same. For example, in case of a ring, for example, in case of a ring, the clockwise and anti-clockwise arrangements are same. then this n minus 1 factorial becomes n minus 1 factorial by 2, because your arrangements are same. So B, C, D, E. Okay, so if you write, what I mean by this is, if you write A, B, C, D, E, it will be same as if you write A, B, C, D, E. Okay. So basically, if you see from clockwise E, from anti-clockwise, it's E, D, C, B. If you see from clockwise and clockwise also, it's EDCB. So basically, if your anti-clockwise and clockwise are basically the same, there is no difference between anti-clockwise and clockwise. Typically, in case of a ring, you will see there is no difference between seeing anti-clockwise and clockwise. Then it becomes n minus 1 factorial by 2. If it is different, then it's n minus 1 factorial. So these are the few formulas or concepts, more than formulas. I'll stress on concepts that we have covered today, and we will be using some fundamental problems and fundamental problems in the subsequent session just to strengthen your understanding. But spend some time, imbibe these concepts with you, and then we come back to the problem. Try some basic problems at home, and then in the next session we will be covering in depth on the problem solving and how to think, use these formulas. We'll be using only these concepts that we have covered in today's session to solve most of the problem. 99% of the problem will be solved by this one, and the 1% that will be different, that we'll cover in the advanced session. But when it comes to permutation combination concepts, you should focus on this only, and you should be perfectly fine. Okay, so hope this is helpful. We try to keep it crisp, to the point, and make it slowly so that you can understand. So if you like this, please like, share, subscribe this video. It will be a great benefit for me. Maybe free for you, but it's very much beneficial and motivating for me to make such videos with you, for you. And see you next time. Have a good day. Thank you.